Okay, so it might, this is continuation. This is part 2. Who knows how many times we'll get a phone call, but it's okay. It's part of life. So right now, what percentage would be between 100 and 160? So this is from u minus sigma. So like right here, they could have written that to mu plus 2 sigma, or they might say 100 to 160 on the test. It just depends. Either way, though, you can see we've got 3 things. We've got 34 plus 34 plus 13.5. So you don't need a fancy calculator for that. You would simply just put it in 34, 34, and 13.5. And so that answer would be 81.5% of the data. Okay, and then the last one says, what percentage would be between 80 and 180? So let me get another color here to help us out. 80 to 180. So right here, all the way to over here. Now there's some cheats. You could say that's 68 and that's 95. So let's do that. So right here, we know this is from here to here. That's 95% of the data. So if I did 95 plus 2.35, I'd get 97.35%. Okay, so that was a little extra bonus there, but here we are on number 3. So it says, to estimate the average number of miles driven by U.S. motorists, a researcher conducts a survey of 1,000 drivers, records the number of miles that they drive in a year, then determine the average. Identify the population and the sample. So again, the population is the general group. So right here, it says find the estimated average of U.S. motorists. So that is your population. And then it says identify the sample. The sample is the number. So in this case, it's 1,000 drivers. Okay, number 4, a pitcher throws 40 fastballs in a game. A baseball analysis records the speeds of 10 fastballs and finds that the mean is 92.4. Is the mean speed a parameter or a statistic? So it's a statistic, and the main reason is because it's from that sample. So this is the population, this is the sample. And so since it's from the sample, the 10 fastballs, that's why it's a statistic. So it's from the sample. Okay, number 6. A researcher wants to determine how many people in the city support the construction of a new road connecting the high school to the north side of the city. 50 residents from each side of the city are surveyed. Identify the type of sample, describe whether the sample is biased, and discuss the bias. So number 6 is stratified. And if you remember, we went through and looked at all of those different ones in a previous, sorry, I'm just gonna look for it really quick and see if I can help you guys to see. Okay, so stratified says that they're divided into smaller groups and then randomly selected from each group. So we had some from each side of the city. So that's why it's stratified. And do you think it's biased? I'm sure it's biased to some degree, but not really. I mean, it might be biased for those who are on one side of the city, but because they did from each one, there is no bias. Okay. Number 7, a research records the number of people who use a coupon when they dine at a certain restaurant. Identify the method. Okay, so let's go to those. Okay, here's your methods. So it wasn't an experiment. It wasn't a survey or simulation. It has to be an observation. They watched it. They saw what happened. And so that's why it's observational. They just made a tally. They were there and they watched it and it happened. Okay, number 8, explain why this might be biased, and it's because when they ask the question, do you think the city should replace the outdated, that word right there, outdated, they are pushing for a yes. And so that's why it is biased. Number 9, a restaurant manager wants to know which type of sandwich bread attracts people. Is the topic best investigated through experiment or observational? My personal opinion is observational, but because I didn't make the test, the actual answer is experimental. And they said that it's experimental because they're going to ask people. I feel like that'd be a survey. I really feel like it's observational because they're just gonna, if it was me, I'd keep a tally or I'd keep inventory of which bread was chosen. But to be honest, I told you I don't like statistics. It's not my all-time favorite thing here. So I'm gonna have to go with what the answer was in your in the book, and it says it's an experiment because they randomly select the number of customers to give each type of bread to and record how many customers from each group return. I would not do that. I would let people choose. Anyways, okay, number 10. A researcher wants to test the effectiveness of a sleeping pill, identify a potential problem if any of the experimental. The researcher asked 16 volunteers. Anytime you see that volunteer who have insomnia, 8 are given the sleeping pill and the other 8 are given placebo. What is happening? So number 8 is, number 10, excuse me. Number 10 is there's only volunteers used. So it's not recommended through doctors, it's not prescribed, any of that, it's just volunteer. And so sometimes volunteers are flaky. Okay, number 11 is talking about this new car wash. So the treatment is the new car wash. I'm going to spare you guys my reading of this. But the treatment group is they get the new car wash, and the control group is people who get the old design of the car wash. Right, so they're testing a new design. They gathered 80 people, randomly divided them. One gets the old, some get the new. That's the new is the treatment, the old is the control group. Number 12 says, in a survey of 1,017 U.S. adults, 62% said they prefer saving money over spending it, giving an interval of the exact percentages. So that is the, the margin of error. And we said that is plus or minus 1 over the square root of n. And so in this case, it's going to be plus or minus 1 over the square root of that 1,017. There's my calculator. So then, again, in your calculator, there's a couple different ways you could do it. You could do 1 divided by the square root of 1,017, just like it says. Or if you like the pretty print, you can hit alpha, y equals, enter, 1 over the square root. Square root of 1017. Either way, it's the same answer, but if you like to see it pretty print, that's how you do it. Alpha, y equals, enter. Okay, so either way, though, I got this 0.0313, whatever. So if I change that to percentage, that's 3.1%. Okay, but they said they gave us 62%. So when we find the margin of error, what we're going to do is we're going to take that 62% and we're going to subtract 3.1 and we're going to add 3.1. And so it said round to the nearest tenth. That's why I'm doing this. Okay. So if I do 62 minus 3.1, I'm going to get 58.9% to, if I add, I'm going to get 65.1%. So that's the margin of error, is 58.9 to 65.1. Number 13 says there are 2 candidates for homecoming king. The table shows the results for 4 random surveys of the students in the school. The surveys were asked whether they vote for candidate A, Do you think A would become homecoming king? And so when we have a smaller sample size, it's high. But the more people they ask, the less likely it is. So with more data, it looks like he's less likely to become homecoming king. Sorry, candidate A. So if it would have gone up, I think this is a previous quiz question too. If it would have gone 75, 85, 95, 97, that would have been a yes. Okay, I have to make some room here for my other ones. Okay, number 14. I miss my old desks. Isn't it sad? I know you all feel bad for me. Okay. A randomized comparative experiment tests whether a new fertilizer affects the lengths and inches of grass after 1 week. The control has 10 sections of land, and the treatment, which is fertilized, has 10 sections of land. The table shows below. So control group, it looks like they kept pretty steady numbers. Treatment, pretty steady numbers. And so it says describe how to use a simulation and resample this data. So you could just keep adding 10 more and keep redoing it. Explain how this allows you to make influences about the data. And I'm just going to show you what they wrote. They said combine the measurements from both groups and assign a number to each value. Let the numbers 1 through 10 represent the data in the original control group, and let the numbers 11 through 20 represent the data in the original. Use random number generator. Randomly generate 20 numbers, 1 through 20, without repeating a number. Use the first 10 numbers to make the new control group and the next 2 to make the next treatment group. Repeatedly making new control and new treatment groups, and see how often you get differences between the new groups that are at least as large as the one you measured. There you go, people.